Hello and welcome to Microsoft Virtual Academy. This course is creating virtual and augmented reality applications on Windows platform. Very snappy title there. And my name is Pete Dekintis. I'm a technical evangelist at Microsoft in the UK. And Module 1 we're going to cover kind of the fundamentals of VR, so we're going to talk through some of the history. And I'm joined today by my co-presenter.
So my name's Lewis Dean. I'm the CEO of a Microsoft Ventures company called VISR VR Reality. We deal in commercial VR for the advertising industry, and I'm here to play the expert and sort of answer some of the scientific and implementation questions around VR and how it should be done.
And I will attempt to ask all of the dumb questions. Okay, so the contents of this course, as I said, we're starting with the first module, which is VR Fundamentals. Where we just talk through the history and give a bit of background and maybe talk about some of the industry and where it is today. And then we're going to move on to Module 2, which is the principles of VR, where we're going to dig into more of the tech. We're going to talk about, how some of this stuff works. And then we're going to get a bit more hands-on and we're going to look at some SDKs. So for Module 3, we'll look at the Alps open source SDK. Yeah. And Module 4, we're going to contrast the previous SDK with Lewis's VISR VR SDK. And in Module 5, we're going to look at kind of user design, user interaction and design in VR and how that differs from kind of traditional app design. And then for Module 6, we're going to have a look and see how to get that app into the Windows Store.
So you can build some excellent experiences and then ship them, which is always important.
Okay, so I think one of the first sort of thought-provoking experiences I had around VR may have involved Second Life. So if you're not familiar with Second Life, it's a kind of alternate world, kind of 3D environment where you can enter with your own 3D avatar and you can kind of wander around, you can chat to people inside there. And it's really eye-opening. It's really quite an interesting experience when you do that for the first time and kind of just entering an alternate world.
Yeah, I think kind of one of the great things about Second Life, it was a showcase for, 3D worlds being more than just a video game. This was actually more a simulation than it was a video game. And the fact that it trended as it did and caught on in the way that it did was a kind of an eye-opener for industry that, people were interested in virtual reality as a medium. It was one of the first platforms to do it properly.
Yeah, and it really caught on in quite a big way for a short time, right?
Yeah.
Companies were holding like events and meetings inside Second Life, I seem to recall.
I think just that the social aspect of a digital economy and a digital social life had never really been done before, and it was a kind of groundbreaking in that way. And it has its own currency system, its own economic problems, and they have people who work at Linden who created it, who are economics majors who understand and manage the economy, and that's was sort of a first glimpse into human persistence inside of virtual worlds can work, and was kind of a great sort of first step for the industry to take.
Yeah, have you used Second Life recently, or?
Not recently, no. Probably about 10 years ago, and it was interesting because I think that they're in this place where they're not quite there yet in terms of what it should be like, but they're rolling out improvements, and I know they've got Rift support coming, and
That's right, they actually have Rift support.
Yeah.
I haven't tried it, but that'd be an interesting one to try out.
Yeah, well, I think systems like this will be important when the next kind of wave of technology arrives that increases that presence and that virtual persistence in that world, and it'll be really interesting to see what happens to legacy systems like this when that happens.
Absolutely,
and how they adapt. Cool.
Okay, so so is this reality or is it just hype? I mean, there's a lot of things now in popular culture which have, over the years. So we've seen films like The 13th Floor. Have you seen The 13th Floor?
I haven't. I said I would yesterday, but I haven't.
I haven't seen it either, actually.
No.
So, but I have seen The Matrix.
Yes, I've seen The Matrix and Lawnmower Man are both fantastic films.
Yeah, I've seen some clips of Lawnmower Man. It's pretty interesting.
Yeah. Well, again, it's kind of asking those philosophical questions of what does virtual environment mean, and is there a point at which you can get truly lost in it? And I think that's probably one of the goals and aims of the current generation of VR, is to see how close we can get to that paradigm. Whether we will get close, this time round in inverted commas or not, we don't really know. But there's certainly quite a lot of powerful companies with a lot of money spending on trying to see if that will happen.
Yeah, I mean, there's one thing that sticks in my mind. There was an episode of Red Dwarf, if the viewers have seen Red Dwarf, where the characters were kind of immersed in a game for 5 years, and they sort of come out of the back of that, and it was really quite an interesting and funny episode.
Yeah. So. Let's talk about money in VR, because that's important as well.
Yeah, I mean, looking at the kind of left side of this slide, I mean, where we are now. So, you know, just beginning 2016, those numbers are quite big on there. So is that 5.3 billion total market value there? Yeah,
so they're kind of looking at, it kind of starts at 3 billion, ends up at 6 billion by the time you're in 2018. And I think that's a kind of a real statement to, you know, who's playing in the marketplace. We've got big tech companies, Amazon are here, Microsoft are here, Google are here, Facebook are here. You know, those kind of people, when they decide they're going to do something, don't do it lightly. So it's going to have a good stab this time around. And it's interesting to see the market cap drifts between being kind of predominantly hardware the first year round, and then it grows to be kind of an equal split between hardware and software. And that's kind of that estimate's probably based on the split that you see in the computer market these days, where you've got, you know, companies like Microsoft, and, you know, you guys had a big sort of a remap a few years ago when you went from being a software company to devices and services company, because actually if you look at the market splits, you know, almost 50% of the value of the market is in the devices. And I think that's probably where people like Facebook see themselves in the future, is that they're going to have kind of Oculus that are going to provide the platform, and then their services, of which, you know, Facebook is a service at the end of the day, they're going to have a services platform that sits on top of that and lets them kind of really take up the market value. So, you know, there's a place in VR for people who make software and people who make hardware. It's not just kind of people like, you know, Valve and Oculus who are just creating hardware. There's going to be a huge software potential, and kind of one of the really cool things about doing this MVA and the hack that's going to be done alongside it is actually, you know, this generation of programmers, kind of you guys who are watching the video now, you're going to be the ones who will be expected to sort of create this software platform that's going to sit on all this hardware, and hopefully you can profit out of it in the future. And
yeah, I mean, would you say it's quite a good time to be getting into VR then? Because I guess from previous years, the investment was a lot lower.
Yeah, I mean, the interesting thing is it's really kind of been turbocharged by all this money. You know, it's the trending topic in Silicon Valley at the moment, and certainly in Tech London. And if you've got a kind of an enterprising VR idea, there's a highly likely chance that you'll get funded to do it. And that's kind of where we came from in the beginning. And, you know, we joined MS Ventures, which is designed around startups with great ideas. And, you know, we're nearly a year down the line, and we're scaling up, and we've had some funding in, and we're working with some great companies. And, you know, it's particularly easy to jump into VR right now, as opposed to any other sort of digital medium. So it's a good starting point, particularly for those interested in 3D graphics or game programming and that kind of thing. It's a great kind of springboard. I like this graph in particular. So this graph is actually from Goldman Sachs. And when you start to see people like Goldman Sachs produce kind of literary information, you start to realize kind of how serious the investment community is taking this. And
So this is actually a projection into 2025, right?
Yes.
And how the sort of market breaks down across the market sectors.
It's a long range look into the future, and how, you know, people talk about VR being the sort of ubiquitous computing thing that's going to disrupt everything, but they don't really talk in finite value about what those sectors are going to be and how they think it's going to be disrupted. And I think this is a quite nice first case of, you know, we've got the significant, you know, military, engineering and healthcare taking up almost as big a space as the video game industry.
Yeah, I mean, so the video games industry on there is obviously the biggest sector.
Yeah.
And I guess we expect that, at least initially, to be what's driving this market. Right? Is that fair to say?
Yeah, I think the thing about video games is it's particularly low-hanging fruit. You know, they are a virtual community anyway. They're used to virtualized simulation products. Yeah. So actually, you know, video game players are particularly easy to convert into VR users because they already understand all the paradigms and how to work with them. And there's a lot of video game developers who already understand how to build virtual worlds and are particularly good at it. And, you know, it's particularly where people like Sony are placed. They understand that developer relationship and the fact they've got to put all the content in place as well as just headsets and devices. And so, yeah, video games I think will be the first sort of toe in the door and starting to push the industry open. But, you know, again, engineers understand virtual worlds and applications of virtualized technology as well. So it'll be really interesting to see how it moves beyond kind of the existing sort of, we're going to make some video games in VR and it's going to be really cool because you can fly around in a ship in Elite Dangerous, and then move that into the future of...
Yeah, I mean, it's really interesting to sort of ponder on some of these sectors, like the live events sector, very different from maybe what might happen in education.
Yeah, absolutely. And I think one of the key things that we always talk about when we talk to clients about VR is VR is this ability to have presence somewhere you can't go. So, you know, if you think about that as a base level, there's so many things that you can disrupt and innovate in. You know, healthcare, you could go inside somebody's body. Live events, you could go to a live event you can never go to. And you know, engineering, you could see a building you're going to build before you build it, just to see if it feels right inside. And you know, all of those things are going to suddenly become possible, and it'll be exciting to see, you know, who grabs the nettle in which particular industry and says, right, all of this is wrong. Now we're going to do it in VR, and what kind of waves of disruption that causes. Cool. Which brings us on to the awkward point.
So we've I mean we've kind of seen this before, right?
Yes.
So back in the 90s, there was a big kind of buzz around VR back then.
Yeah.
So
it was at least as big as this one, and there's the same amount of money in relative terms was spent. So you know the kind of awkward sticking point is, you know, we've all got excited about this before, and it was a complete disaster.
So is the same thing going to happen again, or do you think it's different? Why is it?
I've actually got no idea. So you know, if it does go wrong, we're all going to look really stupid, and that a lot of people are going to look very stupid. But actually, I think there's a kind of a significant technical change that's happened this time around in terms of where we are with technology and some of the enablers and things that have happened that have brought us to this revolution, this decade, as opposed to last time. So you've got kind of famously, there's the Virtual Boy there. That's was a disastrous release project by Nintendo, and that was actually, you know, it was theoretically a good idea, but their key problem was the technology just wasn't there to support the vision. And I think that's kind of really changed this time around.
So what was it about that device? What kind of technology was lacking from it?
Just things like, you know, we didn't have the MIPS and the processing power on. I had a mobile processor from the Game Boy, and that was never going to push a decent VR experience. You know, you look at typical specifications for gaming-based VR these days, £1,000 computers with a few like teraflops of compute performance, and that wasn't going to happen in the 90s in a portable form factor. And so this time around, there's been such a paradigm shift towards this sort of the mobile revolution, and kind of this next slide kind of addresses that. Is actually, we owe this new VR front actually to people like Apple and Microsoft and Nokia, who've been pushing the mobile devices front.
Yeah.
And you know, it's all for the last 10 years or so, because the smartphone revolution has happened in the way that it has. It's been about smaller and more powerful and faster and lighter and higher pixel density and better color representation and better cameras. And you know, the great thing about the smartphone industry is wildly profitable for those involved in it. So they've been pushing back billions and billions of dollars back into this technology cycle of, let's make smaller, faster processors, let's make better, lighter batteries, let's make smaller but brighter, higher density screens.
And I suppose one advantage of that being pushed by the smartphone industry is that we all have them.
Yes, and now everybody owns one, and you actually, you know, as I'm sure will be covered in detail, everybody owns all of the key parts of a technology required to build a VR headset already. And roughly every 12 months, they're going to buy a better version of it. And so that kind of continuous cycle of technological improvement happens without the VR industry having to succeed at all.
Yeah.
I think that's really the key piece that was missing from last time, because last time it was trying to stand on its own 2 feet and invent all its own technology. And now,
there wasn't an underlying technology which was pushing it forward.
Yeah. So it was just wildly expensive, and you know, the first products weren't going to be very good, but then they didn't profit, and it kind of just went. But you know, I think we're in a completely different place this time around, and it's an exciting time to be.
So what can we do now with our smartphones? I suppose it segues us on to the next.
Yeah, so
the
great thing about a smartphone is, in a smartphone you'll generally have a gyroscope, an accelerometer, and a high density, high color representation screen, which is all the parts required to go in a virtual reality headset. The only bit you're actually missing is a simple housing. So actually there's the 2 bits that you're missing is a nice dark box to put it in, and that keeps the light from the normal world away from your eyes. And something interestingly and rather geekily called a pair of calaminating aspheric lenses.
Okay.
Which I won't go into the technical details of why they're called that, but essentially a nice magnifying glass that lets you kind of focus on the screen when it's closer to your face. And that's actually important to bring that kind of the whole display into your field of view. Yeah,
and you can see those on this kind of cardboard headset here.
Yeah, so we've got some
lenses in the front there.
Some that we've stolen from University of Hull, or they've kindly provided. And then we're going to kind of tear those apart later and actually talk about why the lenses are important, what shape they are, and how you can go about building your own if you want to do that from scratch, from like a Kellogg's packet or something like that.
Yeah.
So, moving on. talk about industry key points and why.
Yeah, I mean, there's been some things that have kind of stuck in my mind recently, over the recent years. Oculus acquisition by Facebook.
That was fun. That was the real sort of the starting gun for the industry of, oh my God, you can actually build a company that gets acquired for $1 billion. They paid more than that for WhatsApp, but it wasn't much more. And actually, Oculus compared to WhatsApp had no user base really. It didn't really have an existing community or a content pipeline, and it was bought on the whim that this was going to be kind of a shift in computing, and that was really great because people in the Valley and in Tech London and people who support kind of the growth of this new technology, they all immediately switched then onto this is going to be, you can build an acquirable company. Maybe we should start funding some of these companies to start up. And that was really the kickstart of the revolution, is that you can build a VR company and get funded and come up with a VR idea, and that's started this snowball effect.
I mean, we've seen some other big investments recently, right?
Well, Magic Leap's probably one of the interesting ones that comes out of the blue. It's actually not the biggest total investment currently, but I think one of the interesting things about it is it's totally secret. We know that there's this company called Magic Leap who are doing something that's very interesting, and it's got a lot of people jumping up and down about it, but nobody knows what it is.
Yeah, there's lots of speculation, right, about how it works and what it is, but we don't even know at all what it is. We've seen maybe some promotional videos. Yeah,
I think and those who know what it is can't really talk about what it is or what it does. So, moving on before I defraud myself, we'll go into kind of the next kind of, which is looking into the future of what's going to happen this year.
Yeah, I mean, we're sort of on the verge of some consumer devices being released, right? So yes. Oculus Rift, HTC Vive.
So kind of up until this point, we've had kind of the only consumer virtual reality headset released so far has been Gear VR by Samsung.
Yeah.
Very good job. Very nice technical implementation. Nice price point. But it didn't really fit into any of those market segments that we saw before. It was more sort of a technological demonstration to the community, right? Here's what a nice VR headset would be like. And now moving forward into the next 12 months, we're going to see some proper devices hit the shelves that require kind of $1,500 PCs or game consoles to drive them, and they're going to have a consistent content offering, and they're going to have platforms that support them, and that's new so far, and we've not really seen how that's going to play out. Particularly of interest to watch are the two kind of Oculus and HTC's plays into the market, how they differentiate from each other, because they're obviously quite different offerings. And actually, it's almost a VHS Betamax thing going on, where we'll see who in the industry will sit into kind of, is room scale VR where it's at? Are you going to play it on the couch?
Yeah, I suppose also that having to purchase a PC to go along with it might be a bit of a blocker for some people, and they may have a PlayStation already.
Yeah, so I think that kind of
Sony's
genius move is to kind of, you can probably get hold of this whole Sony package for around $800.
Yeah, so whereas that's more accessible than some of the other, unless you've got a kind of high-powered PC already.
Yeah, and actually a lot of the implementations of VR don't require the power necessary. It's just there to have on the minimum specification. So people like Oculus and Valve can look towards the future and what they want to support.
Yeah, sure.
And yeah, it'll be interesting to see how consumers react to having to spend probably nearly $2,500 on getting hold of the platform. Although from some of the early metrics, they are buying in bulk, and they have adopted the industry. So we'll see what that means for us when March comes around and they start shipping. And then we've got kind of the super future, and this kind of goes back to what I was saying earlier, in this 2017 plus, where the people playing this game are serious players, and none of these people do new technology by halves. They'll either go all in or not do it at all.
Yeah, I mean, we're just seeing huge investments from all of the big players in this space.
And I think it's come to the interesting point, and you look at companies particularly like Alphabet and Apple and Microsoft, where their other businesses are so profitable, they can do it seriously for fun and actually make technological decisions rather than profit-based decisions about building the platforms out, and having a 10-year vision of how they're going to turn it into a new medium and things like that. And having companies of that scale in the industry is exciting, because they can really sort of blaze a trail of this is how we should deploy it. And
yeah, so really from what we can see and what we're looking at, we're at the start of what could potentially be quite a long journey into the...
Yeah, I mean, I don't think any of the larger companies are going to see any profit for years, and that's reasonably respected and understood, because they're in it for the long game or not at all. And they can afford to be in it for the long game, and that's kind of their ace card, is that they have the cash reserves to play a particularly more strategic role in how the industry looks and what it's like. So yeah, and it's kind of super exciting to be in this industry as it all goes along and be sort of swept along with the current and into
Definitely.
the future.
Yeah.
Cool. So
your company,
yes.
Lewis, VISR.
Yes.
Can you tell us about what your role is? How the company started and.
Yeah. So VISR VR is a bespoke virtual reality agency. So we particularly design bespoke cardboard VR headsets around kind of marketing agencies and brands and things that they're trying to do as they go on this kind of fumbling first steps journey to embrace VR. And we have an expert content team and research team who will then help build a content offering around what they're trying to do. So a great example is that University of Hull one that you held up earlier. That's one of our headsets that we designed. Yeah. You know, each headset is bespoke designed for the client. And then we help come up with a VR product that suits them on the software side, and that's sort of the fun part of the business where we get to do science or we get to invent something new. So, for example, we did a project with Wargaming on World of Tanks where we had 360 video cameras on tanks, and you could actually sit on top of real tanks in the commander's seat and actually have a look around as it was driving around an assault course and things like that.
Sounds pretty cool, actually.
So it's implementation of VR and how you actually bring VR technology, into the marketing world to be useful for companies who are trying to use it as a new medium.
So how did you personally get involved in this sort of space and industry? You're obviously quite excited by what's happening in VR at the moment. So how did you get in initially?
Yeah, so when I was back at university, I went to Hull University. You've got kind of a world acclaimed virtual reality research department, which is called Hive. And essentially, back when Virtual Boy was happening and in the first generations of it 15 years ago, they decided they were going to set up a research bureau that was going to investigate scientific VR. So they weren't going to follow consumer trends. They were going to go kind of way out there and see what the industry could be like in the next 20 years.
Yeah.
Interestingly, a lot of the stuff they predicted is coming true. So they were using optical tracking years ago, and they were using kind of stereo pair HMDs years ago. And, so it's interesting to, kind of look at the way they approach VR as a science rather than a company. And I went to university there. So I studied VR under some of the professors that have been doing it for years and got a pretty good understanding of how VR as a technology works. I wrote my dissertation on VR-based projects, and then coming out of university, I ran into Lee Stopp from DX, and he actually convinced us to form into a company and apply for MS Ventures, and that was the beginning of our journey. That was 12 months ago. We're now profitable. We've got an office full of cool people, and we're taking on funding and growing. So. It's that sort of journey from, particularly why I get excited about VR is we went a very quick acceleration from nothing to kind of being 12 months down the line and, playing technology.
It sounds like you really hit the wave maybe at the right time there.
Yeah, we just about saw it coming. I think if we'd have known 6 months earlier, we'd have been in a completely bananas place right now. But actually we tagged onto it just before everybody else did and managed to get the contacts in with the potential customers and start talking to people like Microsoft and Google about where we'd fit in that, and we caught the wave at the right time, and we're sort of growing now and looking to the future, and it's a fun place to be.
Okay, great. Okay, so let's take this opportunity to define some terms in the industry.
Yes, before we run away with.
Before we get carried away,
yes.
We've been talking mainly about sort of virtual reality, but there's a bit more to it than that, isn't there?
Yeah, I think the kind of the virtual paradigm, which is a lovely kind of in quotes phrase that can be used, is basically talking about the way that kind of virtually present data affects our day-to-day lives, and that's the real value that people are seeing in the whole of the VR industry in general. And it'd be interesting to talk about what are the particular verticals that people think are going to be particularly fun or profitable, and what they mean to human beings. Yeah. So it's kind of quite a metaphysical kind of conversation. So kind of the first key point being virtual reality. So virtual reality is this nice low-hanging fruit where you're essentially taking somebody out of the environment that they're in. You're creating a virtual world around them, and you're going to plug them inside.
So you're transported into a completely different place.
Yes. So everything about your world is replaced by a digital one, and actually the kind of the core goal of VR is this kind of emotional feeling called presence. And when you achieve presence, your mind forgets you're in a virtual reality, and that's what you're sort of aiming for.
Yeah, so you truly feel like you're in that alternative reality.
Yeah, you
Second Life.
You lose the sensation of I've got a headset on my head, and you start to make kind of more whimsical thoughts like that's a nice tree over there, or what a cool spaceship I'm on, or that kind of thing. And that's kind of what we're going for in this current gen of VR, is being able to sort of lose yourself in an experience.
Okay, so what about, and how does that differ from augmented reality.
Okay, so
what is augmented reality?
Augmented reality is the idea that data and information is kind of reasonably seamlessly presented in front of you. So kind of the classic example of this is Google Glass. So you've got a set of glasses on, but you've got a kind of a floating holographic 60-inch TV hanging around somewhere out of your field of view that you can glance up at and receive information.
So it's a bit like a heads-up display.
Yeah, a little bit more than that. So there's some cues from the environment taken, but it's not truly environment based. So it's more information is rather kind of blandly just layered over what you're doing. So yeah, a heads-up display with a little bit of intelligent targeting, and you look at AR apps are a good example of this. You've got you might have some GPS pins that you can sort of see what direction they're in, or you look up at the stars and you can see the constellations. But yeah, it's not truly the kind of key defining point is the data isn't aware of the environment that it's in. It's just sort of is there, and that's kind of one of the key kind of defining points for AR and how that's done.
So we've talked about virtual reality, we've talked about augmented reality.
Yeah. So
what's this idea of mixed reality? How does that seems to me to sit somewhere between those two worlds?
Yeah. So it's quite a difficult concept to articulate, but the basic idea is what if the digital things in your life and the physical things in your life existed in the same place? And kind of that's Microsoft's kind of big push for VR at the moment is actually it's this idea of the digital and the physical are indistinguishable from each other, and you blend seamlessly between digital and physical worlds.
So I can have something virtual maybe on this table in front of me.
So for all we know, that might be a virtual object that I'm designing on this computer, but we perceive it as a real object, but it's not there.
Yeah, and you can interact seamlessly between the real world and the virtual world in that scenario. So
kind of the key defining point and difference from AR is it's actually the virtual objects are aware of where they are in the real world. So, even if this was a simulated headset that I've got on the table here, it would know that it's on a table because it's receiving information about the real world from the headset or device that I'm wearing. So, devices like HoloLens, very complicated room sensing capabilities that know the angles of the surfaces and particularly the artifacts and things in the room with you, knows what they are. If they're digital objects, it knows how to communicate with them, and so it's that sort of it's far above and beyond just sort of plastering some fake screens around. It's actually having this blended reality.
Yeah, it seems to me that the use cases of those three things are pretty different.
Yes,
because in a mixed reality scenario,
yeah,
I can use things that are in the real world. So I could use the keyboard here. Mm-hmm. Whereas in virtual reality, this doesn't exist.
Yes, exactly. You'd have to have a totally virtual desk with a totally virtual keyboard, and that's actually almost harder to do because you're starting to, you've got to replace everything. Whereas if you're just playing an augmented or a mixed reality game, you can actually play upon the artifacts you've got around you to help kind of support the illusion.
So let's talk about some of the different devices which play in these different spaces that we've just been talking about.
Yeah.
So the Oculus Rift, it's a pure virtual reality device.
Yes, I think they're kind of these devices kind of sit along those three verticals. So you've got virtual reality, Oculus Rift, HTC Vive. They're kind of it's an enclosed unit with a screen in the end and some lenses on the front. So you're kind of shutting yourself away from the real world and entering this virtual one. And then sort of moving to the right of the slide, you've got devices like Google Glass, so kind of fairly simple optics to achieve the illusion, but it's a nice enough effect. Low power, low weight, easy to kind of integrate with your life, but you're not carrying any serious compute around, and you're definitely not shutting your field of view off away from the world.
That's clearly an augmented reality style device.
And then you've got kind of the end of that, which is the HoloLens mixed reality. It's a much larger device. It does cover your eyes, but you can then see through it to your existing world. And what it does is it uses that lens on the front to kind of project additional information into your eyes. So you perceive this sort of kind of one on top of the other.
Okay, so what is VR? Let's go into a bit more detail about it. So you can see from the slide, the lady there's wearing the glove.
It's very trendy.
Yeah, what's that glove doing there?
So that's a perception touch glove. So basically, it'll have kind of little actuators in the fingers, so she'll be able to feel haptic feedback So for people who don't know, haptic feedback is when a computer attempts to simulate some kind of touch feeling.
Yeah.
So actually, a phone vibrating is an example of haptic feedback because it's it's meant to feel like something that's actually electrical is the idea. So you feel that sort of vibration when you touch it.
So her where she's wearing there, she's got
Yep.
earphones on.
Yep.
So that's replacing her kind of hearing.
Yep.
The viewer's replacing her sight effectively in her environment, and the glove, now replacing touch.
And who knows what's in that
all
box
of her
under her
senses
nose.
are being, transported into this virtual
Yes,
environment.
so it's about perception redirection. So each of those devices is playing a role in redirecting how her brain perceives the world. Because actually, I can't remember if it's an Asimov quote or a famous old quote. There's actually, there's only 6 sensations that tell you whether or not the world is real, and who on earth knows if that's actually how you perceive the world. Everybody probably perceives the world completely different. So actually, if you can start to redirect those sensory inputs, you've only got to replace 6 things, and you've got no concept of where you are anymore. And that's sort of the end goal of virtual reality, is to be able to totally and seamlessly replace those feelings, and so you can be moved into a virtual world without knowing.
Sure. Do you think we'll see virtual smell playing a role at some point? Or
I think more interestingly, it'll be how computers interact with the brain. And I don't think it'll be a box that's producing smell that'll be stuck under your nose. I think we're going to start to see more things that talk with the actual brain chemistry and the wiring of our own brains. And
Sure.
In the next 50 years, maybe. I don't think that's around the corner. But actually, the brain's a big computer at the end of the day, and there's going to come a time when we're going to connect, the big computers that we have on our desks with the big computers that we have in our heads, and that's when that's going to take another sort of quantum leap and drift off into the world of sci-fi. But I mean, we've been doing this for a long time as well, and that's kind of this next slide sort of really, really well illustrates that, is that replacing certain senses with things that are reasonable analogues to them. As we've been doing it for years and years and years, and it's been
there's a lot of history here, right? I mean, going back, looking at this slide, first sort of mentions from as early as 1930.
Yeah, well, it's actually, this is a really nice, it's kind of a practical history example of why science fiction is really important. Because actually, back in the 20s and the late 1800s, there were people like H.G. Wells and Orwell and maybe not Orwell that early, but it would have been H.G. Wells and Asimov were talking about virtual worlds and virtual realities, and almost that kind of fiction inspired the technologists of the day to try and find technological solutions. So, you've got kind of coming up to the 60s is probably when you started to see things that were almost good enough to actually provide a reasonable simulation.
Yeah, and we've got, interestingly, the sensor armour on there.
Yes.
If anyone's sort of had the 4D cinema experience.
Yes. So there's a lot of there's some really cool kind of legacy things lying around. There's a 360-degree cinema in Switzerland that's years old and actually has it's not film, it's a painting. So you go into a room where somebody's painted around you a landscape, and actually then closer to you, you've got models of houses and things. So you feel like you've stepped into this little city and you're overlooking there.
Interesting.
So they've been trying to build virtual worlds in cinema and in art for years, and so there's a lot of legacy projects that you talk about them now. They just sound like bizarre, crazy ideas, and that you wouldn't possibly pull something off by doing that. But that seems sensible, and they did try it. And I think the interesting thing is, in 50 years, people will look back at things like Oculus Rift and think, why on earth did you try that? That's a senseless idea, because the technology will just be so much further on. Of particular interest, I really like this the picture of the flight simulator.
Yeah.
So that's an Avia Sim, Avius? I can't actually pronounce it.
Avia Sim, I think it's pronounced. This was used by the US Air Force?
Yeah, so it was kind of one of the first implementations of a simulator to be used for training pilots. The great thing about it is that, and this is a fact that not many people know, so if you look at the TV monitor, you've got what looks like a rendered you've got a rendered horizon, the pilot's flying around. Yeah. That's not being rendered. That's actually a camera that's on a stick.
Oh, okay.
And it's in a model of an environment, and they have a computer moves it above the environment and flies it around like the plane, because they couldn't render the video.
So it's not actually virtual reality, it's sort of real reality.
Yeah. But then kind of with a virtual twist, and that movement is based on a physical model of what an aeroplane would be like, because that's the only thing they could fit in the computer. So there's all these kind of lovely old hacks of ways they used to try and get it to work. And again, back to that point, it'll be nice in the future when we look back and it'll seem archaic, the kind of stuff that we're doing now. You put a smartphone in a cardboard box, what are you doing? And
it's pretty crazy.
Yeah.
So, you know, it would be remiss of me not to mention the ViewMaster.
Yes,
of
I love
course.
the ViewMaster. I had a ViewMaster.
I had a
I'm sure
ViewMaster
you had
as
a
a kid.
ViewMaster, yeah.
Yep. And you know, it's the same, really the same techniques that are used today in virtual reality.
Still exist. And in fact, there's some amazing Victorian stereo rendering photo systems where you'd get photography, you know, left-right image, and then you've got a set of horrible big thick lenses on a wooden stick, and you'd look through it and you'd see a stereo image.
Yeah, I think I've seen those things actually.
So actually, stereo photography is not new either. And one of the things you learn, you know, definitely when I was at university, and anybody who's at university at the moment will know this as well, is that, you know, one of the big things that university lecturers pass on is don't bother inventing something because somebody will have done it 30 years ago. Just go and look for it. And you know, that here's some classic examples of, you know, they knew that stereo photography was a thing on how to do it quite a long time ago. I know that actually the RAF used to use stereo photography extensively in World War II. So they would fly down one path, fly 10 miles along in that direction, then fly the path again, and take a load of photographs. And what you get was a stereo photo of a little model of what the terrain was like. You could actually pick out features and things. So, you know, they've known about stereo for a while, and stereo has been a popular technique for quite a long time.
Okay, so we haven't just invented something then.
Nope. We've stolen it and called it technology, which is kind of what we as technologists do.
Of course. So here you mentioned the Virtual Boy earlier.
Yep.
Here we have it again. It's made another appearance.
Yeah. So this is kind of the, you know, we've tried this before. It didn't work out too well last time. The interesting fact is, so the Virtual Boy was the brainchild of the guy who actually designed the Game Boy.
Yeah.
And you know, we look back and he's kind of this master of technology who decided that gaming was going to be portable and everyone should have one in their pocket, and that's seen as a sort of genius stroke. And his next idea was this virtual game console. I mean,
when I'm looking at that picture, it doesn't look a million miles away from what we have coming out later the year. Maybe things are smaller and the technology is better all round.
Well, it's not actually any different. You've got a pair of those trendily named, you know, aspheric laminating lenses and a display. And I think the main key point was the display technology wasn't there, and the processing technology wasn't there, but the idea is exactly the same. And so it's interesting to see that now, you know, you look particularly at Oculus Rift. The original kind of development kit Oculus Rift is awful, and you know doesn't deliver what we'd even now call a decent VR experience.
Yeah.
But you know that kind of, if you look at comparable Oculus products now, just 3 years later, how quickly the technology's moved forward, and how quickly it is going to move, and that's again driven by smartphones and the smartphone industry. It's going to be kind of so completely different to the last times.
Okay, and we're seeing there's quite a lot of devices now. There's different types of device.
There's been a device flood. I think kind of the most popular ones are smartphone driven. So, you know, going back to the original point of everybody owns a gyroscope, a high def screen, and a mobile graphics processor that's powerful enough to render stereo.
Yeah.
You know, it's very easy, and we at VISR do it. We jumped on that bandwagon as well. It's, you know, you can create a VR experience from not very much. The key point is then what you do with it further, and I think that's where some of these companies that are, you know, they've gone to Shenzhen market in China and they've got someone to do an injection molded plastic thing and they've called it a VR headset, but you know it's not supported by software or a platform or a real clear strategy of what the users are going to do when they've got it. Yeah. And that's kind of interesting, you know, and Fibrum's up on the slide, which is interesting because they are taking a slightly more involved approach about how they're building their community and supporting it. And
so they have an SDK and they have a controller.
Yeah, so they're looking at kind of bringing a proper product offering, which is good, and it's exciting to see.
Yeah.
And we've got the same thing with VISR. So you can go to the VISR store and buy a cardboard headset, but we've got a developer section on the website. We're going to be making this SDK of ours open source by the time the VR hack happens.
Yeah.
So kind of we're really looking to kind of push that, you know, the community and the developers, as we saw in that kind of 50-50 graph between devices and software, they're kind of as important as just shipping a box with some lenses in.
Yeah.
And then you've got kind of, you know, what the other players are doing. They're moving into kind of more bespoke offerings.
Okay, so let's just move away from VR for a second.
Yep. It's nice and in depth that was actually.
Yeah, it was.
Hopefully, there's no more questions left in anyone's mind.
I think we covered most things there. Yep. So let's just consider what augmented reality is.
Yep.
I know we touched on it a bit earlier, but let's maybe look at it in a bit more depth.
Yeah.
Maybe some examples here. So we can see the Google Glass there.
Yeah. That's kind of the one everyone knows when you talk about AR, Google Glass, because it was kind of a first push into how they might use that as a technology. It's actually a colossal failure, but you know, as technology goes, nothing is really a failure because we didn't know all those problems before we tried. And now we think more carefully about how you implement.
Yeah, I mean, it's brought a lot of kind of the social questions about privacy and so on.
And it's nice that those get asked and are used. And then you've got kind of some more unheard of products like this very stylish looking Epson.
Epson, yeah, I haven't seen the Epson, but I believe you can buy a developer version of this now.
Yes, you can. I think they're doing some interesting stuff with kind of laser projectors in the lenses, which is going to sort of bleed into that mixed reality kind of technology in the future. It's interesting to consider that the headset only looks stylish if you have that hair.
Yeah, you need that kind of glossy, sort of model look.
So I don't think we'd look particularly good in them. But yeah, we've got this current problem, and we're trying very hard to move away from it. And again, mobile technology, constant miniaturization, constant light and battery improvements, that's going to really help.
Yeah.
But kind of at the moment, it's a bulky, not spelt like we do, but a visor that sits on your head and is sort of it's a large, bulky device because it's got to carry all this compute with it.
It's just unavoidable at this time, but we expect,
It's going to get there. It has to get there.
So some AR products here. So so the one there on the left is a game app.
Yeah.
And if you go into the game store and you point the app's camera at a product, it will recognise that product.
Yeah.
And use its services to bring information about the product, like it will play a video overlaid on top of it. So
this is sort of typical application of AR. So you've actually got, it's not depth sensing, it's not trying to understand the environment, but it's seen something that it's providing as a data point, and it says, right, I'm going to draw on top of that a square window with some video in.
Yeah.
And actually, if you look at the AR kind of mapping application in the other slide example, it's the same sort of thing. We've got
the City Lens app that's on there, right?
We've got some rough hints, and we're going to kind of do our best to put together something that looks reasonable.
And as you turn the app around, it knows where it's pointing, right?
Yeah.
And it will overlay in that direction.
Some cards. Based on distance, actually. So that's kind of using GPS and using the compass. So
so the ones at the back are further away.
Yes,
is what we're saying. The ones that are smaller on the screen.
And they're sort of, that's getting there, starting to take sensor cues from other devices and looking at how the data integration's done. It's not mixed reality, but you can actually get pretty good AR. I think they're going to kind of struggle with how that gets further integrated and whether or not mixed reality and AR become the same field in the future.
Yeah, I can see that scenario. So this is what we're talking about though now at this point in time when we.
So if you talk about augmented reality, it's usually Google Glass is quite a nice standalone out of that it is a headset and it does have an optical system, but generally augmented reality tends to be a camera that you look through that's presenting information on a smartphone display, and they call it the actual industry term is the magic window. So you kind of it's the idea that you're surrounded by this data, but you can only see it by looking through a magic window.
I see. That makes sense. Yeah. And onto the Microsoft HoloLens.
Fun stuff.
Again, it's quite sort of secret.
Yes, not much that we can talk about or can reveal, but the basic idea is that devices like HoloLens support mixed reality through the use of really custom hardware.
Yeah.
Because there is, going back to this, you can't carry around the compute power required for that big Epson headset. So actually, some of the interesting things that HoloLens is doing, and I presume that Google and Magic Leap are doing together as well, is they're looking at custom hardware that's built to understand the environment, and having a sensor platform that supports understanding, rather than something very simple like AR where it's sort of hacked together. This is actually carrying incredibly complicated sensors, and it's doing quite a lot of complicated mathematics to put this picture of the room together.
Yeah, and that's, as you say, that's driven by the custom hardware.
Yes, so you've got it's termed the Holo coprocessor, which kind of was talked about at the devices show that Microsoft did a few months ago, and that's particularly designed to understand environments, and quite fun.
Yeah, and we're seeing, if you go to the HoloLens site, you can go there and view some of the sort of product ideas, and some of the demos and so on. And we've got on the slide, we've got the NFL demo. Yeah,
this is a really interesting one. So this is the blurring of reality here and reality somewhere else. So there's no virtual here. It's all real information, but you can manipulate the real world and bring it, do things with it, send it somewhere else, present it to somebody, and that's a really interesting use case, because that's not only is that going to have implications in the VR world as well, but actually that's never been done before, and it's this first step towards kind of compute everywhere, which was kind of Microsoft's vision.
Yeah, I mean, this one's quite interesting because this is purely a consumer scenario, it seems to me. Whereas, I mean, we touched on earlier enterprise uses, you know, where maybe an architect builds a building, and people can actually go and experience that.
I think I mean, kind of, you look at this slide here. So this is kind of this is an industrial use of augmented reality and mixed reality, and you look at the computational understanding to look at a bike and figure out where the virtual parts on that bike are insane. They're actually they're orders of magnitude above what you can do on a smartphone and everything else. So it's a really clever device. What it's doing to understand the environment is really clever, and that's why it's going to produce that paradigm shift. And the Microsoft strategy originally and at the moment is, let's go for big industry, because big industry are about the only people who can afford this insane processing power. But big industry have always been the drivers of things that are consumer grade.
Yeah, and I suppose in this diagram, this motorbike doesn't exist.
Yeah,
in the real world. So,
well, it's even more interesting actually. Half of that motorbike does exist. So if you watch the original promo, the chassis exists, but none of that kind of plastic fairing exists, and the designer's designing the plastic fairing to fit the chassis. Yeah,
that's interesting. So the designer there is using a finger gesture.
Hollow gestures, yes. There's a name for that. I think it's called intents or something. And basically, you're reading your hand twitches to kind of invoke action on holograms. And yeah, that's kind of, we have a design house. We design product like this. That I'm really excited about how that can change our business and the way we do things. And I think, that we talk about a lot about low-hanging fruit. Who's it's going to be immediately available to help, and they're obviously going to be the drivers of the industry. So particularly for HoloLens, I think designers, mechanics, people who need to understand how things work, but can't necessarily see that data up front, are going to be an easy kind of first consumer.
Yeah, and being able to experience just things that were never possible.
Yeah.
Like, the surface of Mars, for example, which is another one of the...
Yeah, which is a great project.
Yeah.
But that's about stereo photography, so we'll probably talk about that later.
Okay, so let's move on. And here's a little clip of kind of deconstructing the hardware of the HoloLens.
Yeah, so I think that the interesting... What's quite cheeky about that video is all the interesting stuff flies out very quickly at the beginning, so you can't talk about it.
We could slow it down.
Yeah. But yeah, basically this is going back to that kind of, it's a suite of sensors. It's not just kind of a display system with a processor, and it has this kind of very large sensor volume understanding of where it is in the world, and it's making interpretations of what it sees and what those objects are and what color they are and what kind of objects they are and how far away they are, and using all of that data combined to kind of compute what is my place in the world. And then when you truly understand that from a computing perspective, you can drop things in it and they'll make perfect sense.
Yeah.
So the particularly the Holo coprocessor, and what it does is all about that sense of understanding and things like that.
Okay, so that's the HoloLens, and I want to quickly talk about another project, which is it's kind of similar in some ways, right?
It's an MSR project, so it's kind of, they're always slightly in the sky and interesting. But yeah, Room Alive, basic concept is that we have sets of depth sensing cameras placed around a room, and they're paired with sets of projectors. So if you've ever seen projection mapping done as part of a light show or a stage concert, the idea is that you project with understanding of the surfaces that are in front of the projector, so you can do things like live green screen where you're cutting out.
So I can, so again, the same way that the HoloLens mixes reality, I can do the same thing with Room Alive in my front room.
Yes, but in this case, it's collaborative, because you're not seeing the world through a magic window. You're actually projecting the virtual information directly onto the surfaces.
Yeah.
Which is quite interesting and quite fun.
Yeah, and I suppose another interesting aspect of this is that there is an SDK.
Yes.
And you can go and buy this hardware.
Yeah, well, it's nicely open source, as kind of Microsoft's pushing this open source agenda, and it's nice to see stuff like this. Just some researchers in a room came up with it. Microsoft's not sure about the product fit, so let's open it to the community and see what they come up with. And I'm interested to see kind of how community hacked Room Alive projects emerge and what they do with them. I think actually of particular interest is the how you would place all of that in an entertainment setting, and places like kind of a laser quest or a bowling alley where you've got this augmented data is sort of just floating around on the floor and stuff like that. Would be interesting to see. Yeah,
it's interesting. It's like a blank canvas, right?
Yeah, and that's the great thing about kind of virtual or augmented anything, whether it's reality or technology, or there's so little that's been defined right now. you know, where we're going in the
really
future
is
is completely
an
unwritten.
open playing field.
Yeah. So let's talk about people who like to look like that.
Yeah. Do you have to look silly to?
Yes, absolutely. Well, interesting. We've done some studies actually, and you do look silly, no matter how cool the technology is. So even if you're wearing a HoloLens, you look silly. If you're wearing an Oculus Rift, you look silly.
Okay, so we just have to get over that.
Yeah, I mean, it can be argued that this guy looks no more silly than, you know, Palmer Luckey trying it on with his billions of dollars and his technology company that's doing it. You know.
Yeah, I think it looks quite cool apart from maybe the tape on the front.
Yeah, I'm not sure what the tape's holding on. It'll be probably the screen.
So I suppose the point here is that you can build it. You can build one yourself.
But it goes back to you know to keep harping on about it. But smartphones, you've got all the complicated technology, the stuff you just can't build. You know, you can't build a motherboard with a smart processor on it yourself. You can't do it without a $100,000 facility. You can't do screen integration into that device. You can't build the screen driver. You can't build the operating system in any amount of time that would be reasonable. I'm sure that someone will now go off and do that in a hackathon and come back with a custom VR headset they designed from scratch. But the tough technical integration is done. The bit that you're missing is a dark box and a pair of lenses.
Yeah, maybe we should talk a little bit about how you could build the dark box.
Yes. Well, the most interesting and easiest way that we found, and it's why we do it, is just a cardboard box. Everybody's house is full of cardboard. Cardboard's a great substrate material to build kind of physical, mechanical objects out of. So this is one of the headsets that we designed. So it's a cardboard box, but within it there's quite a few layers of complexity. There's mechanics in here, there's optics in here. But actually, cardboard is a substrate that you can cut out very easily. It's actually reasonably precise. It's actually fairly rigid. It's a really good starter material because there's no special equipment or tools required to do it, and that's why it's been embraced by the hacker community, and things like Google Cardboard and things like VISR have come out because you can just pick up and get started with very little experience, very little tools.
So you could effectively you could get a sheet of cardboard,
yeah,
and you could cut that out,
yeah,
fold it up, purchase the lenses,
yep,
slot them in.
Yes. And we're going to be selling the lenses. This is not a plug, but actually one of the things that I'm really passionate about is the maker community. And we at VISR spent a serious, probably about 6 months of full time for 10 people, figuring out the best way to make lenses for cardboard VR. And instead of us trying to kind of bundle that with a headset, we're going to just be selling those.
Are you selling them lenses separately?
Yeah, community people can just pick the lenses up. If you're really interested or passionate about fabbing your own headset, or you want to 3D print one, so you can pick up those kind of really good quality lenses and get that great quality picture.
There are some other ways you can make the dark box, right? I mean, you can do Ovis Dive. You can 3D print the.
So yeah, I mean, essentially, it's a black box with a hole in the front for the lenses, and anything that you could build that out of. We've seen ones that are made of leather. We've seen ones that are made of metal. We've seen really good ones made of neoprene and foam, and there's so many different ways that you can build the enclosure, and it'll be interesting to see how industrial designers kind of take that forward and hackers and makers decide. I think particularly FDM 3D printing and the impact that's having on the maker community definitely means that a lot of the parts of the housing of a VR headset, even plastic parts, you can print at home now. If you've got access to a 3D printer, or you've got a friend has got one, you can just create the enclosure, and it doesn't have to be anything special. It's just got to fit the phone in the end and have some lenses in. So yeah, it's a really interesting kind of fun take.
Okay, so that covers the kind of the headset part of it. Yep. And so let's talk little bit about the software. And we've seen a couple of VR apps in the Windows Phone store. Yeah,
so I think the kind of the way that kind of Windows Phone's kind of evolving as an ecosystem is there's not really an established core amount of content there yet.
Yeah.
There's loads for Android because obviously Google are pushing that platform, but hopefully things like this and things like the hackathon are going to start kickstarting that kind of Windows Phone driven store approach. You've got a few really nice ones. So there's Neuron, and there's some ones that have been produced by Fibram, and Fibram is a company that makes this kind of VR platform that I was talking about, and they've got a plastic headset and an SDK.
Yeah, there's quite a few games that they've been made using their SDKs, and they're in the 5 or 6 games there, which are quite interesting to go and try out.
No, they're really cool, and they're really nice implementations, and it's a good sort of jumpstart into VR. We'll talk later about kind of when we talk about SDKs why some of the sensor implementation isn't particularly great. and things that can be done to improve those. So if there's anyone from Fibron watching. But yeah, essentially we'll talk about implementation and the great thing about these is they show a really good showcase of what it can be like, because they've invested heavily in the artwork and the game design is reasonably nice, and
So these are the kind of games that we're going to show how to make throughout this course. Right?
Yes, and particularly in the design section later, we'll talk about implementation design and how you actually build experiences that don't make you sick, and they get you into VR in the proper way, and that's far more important actually than the technology and the cardboard box with the lenses in and everything else. So that's a kind of interesting place to start. So we've sort of reached the end of what we were talking about.
Yep, that concludes the VR fundamentals module.
Yep.
So in the next module, we're going to talk about the principles of VR. So we're going to kind of go from scratch, aren't we?
Yeah, so it's more interestingly building VR yourself from scratch, not relying on an SDK, which is really great. You'll be able to kind of form an understanding of some of the things we talked about and how you would pull them off yourself. And we'll see you in the next module for that.